Okay. Okay, next one. Okay, this question is a bit challenging. I have a list of answers. This is marked as one of the tough questions. Let me just screenshot and explain to you. Okay. So let me just screenshot this one. Let me put in my pen program here. Okay. So let's discuss this one. See how. Okay, I need to shift something away. Okay, let me try to work on this one. Okay, this one say an application with a microcontroller requires that the user closes a switch. Okay, and then the LED will be turned on for a second. Okay, so if you look at this one, okay, when the switch is closed, you want to turn on the LED for 1 second. So likely C is to turn on LED for 1 second. Okay, for 1 second. Okay, this is to turn LED on for 1 second. Of course, A there will be to start and D there will be to stop. Okay, so this is the decision making. Okay, so under what condition should it be waiting here? And under what condition it should be coming down here? Okay, you look at the answer. Okay, if you look at the answer here, A is start, correct? Okay, then D should be end. Okay, so these three are correct. Okay, okay, A is start and D is end. Okay, then C should be to turn on LED for 1 second. So both these two are correct. Okay, turn on LED for 1 second. Then you compare the two answers. Okay, oops, that's very irritating. Okay, so is B checking for switch close or is B checking for switch open? Okay, so if you look at the question first, okay, look at the question again. Okay, it says close a switch, then you bring an LED, meaning that this path, okay, means switch is closed. Okay, switch closed. Then you will move on to turn on the LED. Okay, then what should the question be asked here? In order that no is switch closed. Okay, no is switch closed means that you are asking is switch open or not. Okay, you must be asking is switch open or not. Correct. Okay, then you say no. Okay, then it must be switch closed. Okay, because only when switch closed you'll be turning on the LED for 1 second. So the answer should be this one, is switch open. C is the answer. Oops. Okay, this is one of the harder question which I marked with an asterisk in my answer. Okay, so C is the answer. Okay, you are asking is switch open. So if no, okay, that means switch closed. Then you go and turn on the LED. Okay, I hope you understand this particular question. Some of the questions are slightly tougher. Okay, next one. This one is quite simple. Okay, you have a typical traffic light control. Okay, you have three lights. Traffic lights are red, amber, green. Pedestrian light are red man, green man. There are a 2-digit 7-segment countdown display. Okay, buzzer is hidden behind each pole here, and then there's a button on each pole. Okay, so the question asks you, okay, this one be careful. Okay, select the correct statements. Okay, that means this is a multiple select question. Okay, so actually in this case, there are a few correct answers. First one, there are only two inputs, the two push button, correct? Okay, one here and one here. Okay, two push button. Second thing, say the traffic lights, countdown display, pedestrian lights, and buzzer are all outputs, correct also. Okay, the traffic lights, pedestrian lights, countdown display, and the buzzers are all outputs. Okay. Actually, there is another set of pedestrian light here. Maybe another set of traffic light somewhere. But okay, it's a correct answer. Okay. Now next one, countdown display can be controlled by 14 GPIO pins. Okay, I'm sure you know that each 7-segment display, if you don't count the decimal point, there are actually 7 LEDs. Okay, so 7 pins. This is another 7 pin, so 14 pin, correct? Now imagine you have another 7-segment display, 2 digit here. They can be controlled by the same set of signal. Okay, that means maybe port A, pin 0, control this one, and also control the same one on the other side, because it's the same action, turn on, turn off together. So 14, correct. Now why is this one wrong? Okay, this one is obvious. Let's say the countdown display is input. Okay, this is an output, not input. Okay. Okay, so let's move on to question 10. Okay, again, this is okay. I don't know whether you know. Okay, actually the questions may tell you whether it's a multiple select. Okay, when you see multiple select means you should not just choose one or the best one as your answer. There may be more than one answer, and you have to tick every one of them. Okay. Now, when using microcontroller board for CDIO project, which one should not be made? Okay, so there are a few answers here. First one, to drive the 12-volt DC motor, okay, connect 12 volt to VCC. This STM32 can only stand 3.3 volt as the power supply. So if you connect 12 volt, you're going to damage the microcontroller. Okay, so this should not be done. Okay, now the DC motor. Okay, maybe I show you the motor circuit. Okay, this will highlight to you what is meant. Okay, this is the thing. Okay, let's say I have a STM32. This one should be 3.3 volt power. Okay, so if I have a DC motor that require 12 volt, the 12 volt can be connected here. Okay, connected here, and then I use a transistor. Output a high here. Okay, the transistor will turn on. Okay, and then the current will flow through the motor. Okay, from the 12 volt through the motor to the C, E, then to ground. Okay, of course the motor will turn. Okay, when I turn off, okay, the transistor will be turned off. Okay, then this shunt diode actually provide a path for the current to slowly die down. Okay, so the 12 volt should be connected here, not to the microcontroller. Okay, this one, okay, this 12 volt supply to the VCC. Okay, actually this VCC, okay, can be a bit confusing. Okay, that VCC doesn't refer to the VCC in this circuit. It's actually the VCC of the STM32. Okay, so this is not appropriate. Okay. Okay, the second thing is the I/O ports can be configured as digital inputs or digital outputs. Okay, I think for DC motor, okay, you should configure it as output. Okay, so B should not be the answer. Okay, B is the only answer that should not be selected. Okay, let's see why the other two. Okay, this one should not be done. Wait. Let me rewind a bit. Now I'm a bit puzzled. ACD. ACD is the answer. ACD. In order to keep the input always 0. Okay, sorry, let me just check on this answer. I think there's something wrong with the answer provided. Let me pause the recording for a while. Okay, let me go and check. Okay, let me continue. Okay, we were at question 10 just now. Okay, I was doubtful about certain answers. Okay, so indeed this VCC means the VCC of the microcontroller, not this VCC. This VCC should be 12 volt. Okay, now second thing, you're using for CDIO project. Okay, so the I/O ports can be configured as digital input and output, correct? Okay, but if you're using DC motor, of course that should be an output. Okay, so this one should not be selected. Okay, you can configure the pin as input output. Okay, this one, in order to keep an input pin always 0, connect ground to that pin. This one is a bit dangerous, because if you connect ground to one pin, okay, and then you make a mistake, okay, and make that pin an output, and you produce one which is 3.3 volt, you're actually shorting 3.3 volt to ground, okay, without any resistance. Okay, I think you know what I'm saying. Okay, let me just quickly show you the concept. Control A, Control X. Okay, so let me just show you the concept. Okay, you see, first thing, let's say you have the STM32 here. This is your STM32. Okay, let's say you have a pin. Okay, let's say this is a PA pin 0. Okay, if you connect to ground, okay, like that. If you want it to be providing input of 0, okay, 0, okay, you connect to ground this way. Okay, there's a danger because one day you may forget, and then you produce, you make this pin an output, and you produce a logic 1 here, okay, which is 3.3 volt. Okay, now this is going to cause a huge current to flow because there's no resistance here, and the thread here, the copper thread here, will be burned. Okay, maybe the pin will also be damaged. Okay, so it's not proper to do it this way. Okay, if you really want to connect directly to ground, you should at least put a resistor here. Okay, just to protect the circuit. Okay. Now, okay, this one is also the wrong answer. This is a wrong answer. 5 volt should be connected to VDD. Okay, VDD actually stand for the higher end. Okay. Ground should be connected to VSS. Okay, so it's shown opposite. Okay, so you should not do this one. Okay, so this is the answer. This is the answer. Okay, connecting ground to the pin is not appropriate. Similarly, okay, the 12 volt should be connected to the BJT transistor that side, not to the STM32. Okay, so only this one is correct. Okay.